Okay guys, it's me Imad. So today in this video tutorial we will learn about how to make a program for LED dimming within the simulide simulator. The microcontroller which we are using is the Arduino Uno. So how we can do that? First of all, we have to go to our search components section, and here we will search for our microcontroller. So here it is, that is Arduino Uno. Okay, now we can click on zoom to fit, and now we can see it properly. Now you can see that we have all sort of pins available, that is all the analog and all the digital pins. So as we are dealing with the pulse width modulated pin, so we have to right click on the microcontroller and click on horizontal flip. Now we got all the digital PWM pins on the right hand side. Now we will take our LED. So this is our LED, so click on it and drag it out. So we can connect it with the any PWM pin. So here we will connect it with the pin number 9 and also with the resistor. So this is the resistor, connected like this. So this is the ground, and connect ground with that of 100 ohm resistor. Why we have introduced this resistor? Because we have to make a current limitation, because 5 volt is very much dangerous for this LED. So we have to introduce a current limiting resistor. And obviously the some of the voltages will be dropped on this 100 ohm resistor as well, so our LED will be safely operated. Okay, now this is our LED and the resistor. And now we will introduce a potentiometer. Why it is so? Because we have to we need a dial or knob for dimming of LED. So we have to take this potentiometer, we can do one thing. As we need to connect this potentiometer has 3 pins. 2 are the side pins and the middle one is the wiper pin. So we need to connect this wiper pin with that of analog 0 pin. Now analog 0 pin is the analog to digital converter pin. Means that this pin has been internally connected with that of analog to digital converter. So this is our A0 pin. We need to connect it like this. We need to connect our other side of the potentiometer with the ground. So we will take ground like this, and we will apply voltage via fixed voltage power supply. So this is our circuit. Click on zoom to fit like this and connect it like this. So now what will happen? Whenever we will rotate our knob of the potentiometer, what will happen? It will change the voltage. It will, with the help of this dial or this knob, we can increase the resistance, we can decrease the resistance value. And obviously when our resistance will increase or decrease, it will change the value of the applied voltage on the pin number A0. Whenever we will get a low voltage, our LED controller will send such commands in the form of PWM waves. And these PWM wave will actually change the voltage. And hopefully you know about the pulse width modulation, that in this PWM we can control the pulse width of the waveform. Means that if we want to increase the voltage on the pin number 9, we have to make on, or we have to increase the duty cycle of the waveform, so our voltage will get increased. LED will get more voltage and obviously it will become more bright, and like this. So now this is our circuit. Now we will go towards our Arduino IDE, so we can click on it and double click on it, and now it will open. Like this. So now we have two functions here that are already declared, that is while setup and while loop. While setup executes for one time, while loop executes again and again. It is just like a forever loop, like while one or unlimited for loop. So here it is while setup. So here we will do one thing. Okay, we can write here like serial.println serial.begin. Okay, sorry, serial.begin 9600. So what is this? We have initialized our serial communication protocol here with the baud rate of 9600. Why we have written this thing? Because we want to observe our values of the potentiometer on the serial monitor. You have to wait. I will attach the serial monitor and then you can see all the values on this serial monitor. Then in while loop we will declare a variable, that is int a is equal to analog read of a0. Means that our analog read function or command will read the value of the signal, okay, which is coming on a0, and then it will be stored inside this a variable. Okay, after this has been done, we will map this these values. Okay, so map a, we will map our signal on x-axis it is 1024, on y-axis it is 256. Why we have written these things? Okay, 1023 from 0 to 1023 means that we will take samples, okay, of 1023 means that we will go for 1023 sampling rate. Means that our map function will actually map our signal on 1023 sections on the x-axis. And what about this y? We will make certain levels of the magnitude of the signal which is on the y-axis. Like this is the from 0 to 1023 it is the x-axis, okay, parts, and from 0 to 255 these are the levels of the magnitude or y-axis. And then all the things will after mapping, all the things will be stored inside this variable b. Okay, after this has been done, we will go for analog write what is this? It is b. Okay, we will write 9 comma b. Means that the value will be given, this b value will be sent on the pin number 9 in the form of analog pulse width modulation. Analog write is a function that will just write an analog signal, but it is not like you can see that we are just dealing with a sine wave. We are just dealing with a pulse width modulated wave. So if you want a more voltage on the pen, we will just increase the number of the B or the magnitude of the B, and our voltage will get increased. Okay, so and obviously we will write delay here, delay of like 50. It is enough for this, so we'll run it out. And it is done compiling. So now we will go for our hex link. We will copy it out, this hex link. We will copy this hex link, Control C. We will go to our microcontroller. We will go to the properties. We can paste the link here, and firmware successfully loaded. Now we will run it out. Okay, we will make it like this. Now you can see that by okay, we can okay. Now we also need to take serial monitor, as I have said to you. So it is so we will take serial terminal. We will connect our serial terminal RX with TX and TX with the RX of the terminal, and we will open it out like this. Okay, like this, and run it out. Okay, we will do one thing. We will change like coding a bit, that is serial.println value of B, that we also want to see the value of B as well. So now again right click, go to properties, again this, and firmware successfully loaded. Again run it out, and now we got 226. And now we will decrease the value, and you can see that it is decreasing, and like this. So now on 8 it is completely 0. So now you can see that our values are increasing, and now our LED is a little bit on. Now its light is increasing. Just okay, so we can make it light dim. Okay, like this. So in this way we can make it bright, we can make it dim, and like this we can control any other device. So hopefully you got the concept that how you can make an LED dimmer with the help of Arduino Uno. So thanks for visiting our channel, and don't forget to subscribe.